The Easy Living project at Microsoft Research is developing a vision of computing in the future home or office, in which all devices are integrated into a single intelligent system. Earlier this week, we videotaped a scenario in the Easy Living lab so you could actually see how the system works. What you're seeing is the Easy Living lab. It's set up very much like a shared lounge in a typical office building. It has places for sitting, for talking, and for working on the computer. When I entered the room, the lights were automatically adjusted. This is made possible because the Easy Living system has an awareness of the room and its occupants. When I sat down on the sofa, the screen automatically woke up for me. I decided to check my email. Once I log in, I can bring up my personal computing session. And it looks like I have a new email from Brian, which includes a document I need to revise. Rather than working from the sofa, I moved to the computer where I could be closer to the screen. The computer noticed I moved, and it put my session up on the PC for me. Hey. Hi. The PC acknowledged Brian's presence by bringing up a toolbar. He then identified himself using the thumbprint reader. So what's up?
I got my pictures back from Africa. Would you like to see some of them?
That'd be cool.
I'll put them up on the wall screen.
Please do.
You see this lion? You think this lion's close. But look at this one.
Very nice. That's really neat. There's one work thing we got to look at. Can I put this up there for you?
Sure, go ahead.
Yeah, it's about this title. Is it okay if we change it from intelligent environments to ubiquitous computing and the role of geometry?
Yeah, I think that works better. Well, I better get going. I'll see you later.
I'll be right behind you.
Goodbye.
That scenario showed you the sort of things that the Easy Living system can do. Now let's see what makes it work. The Easy Living system works by providing three key features: awareness, integration, and automation. The Easy Living lab has an awareness of who is in the room and what devices they are trying to use. People are tracked in the lab using 3 stereo vision cameras. Each camera provides real-time depth and color information to a computer program that determines where people are located in the view of each camera. Here we see John walking around in the lab. The following display shows the key steps in vision processing that occurred during this time. The upper left image shows the raw depth data from the camera. The upper right image shows the background model, which includes color information for regions where depth information is unreliable. The background model is subtracted from the incoming images and then segmented to produce the moving shapes, as shown in the lower left. The lower right image shows the result of filtering of these shapes, looking only for shapes that might be people. The location of each person shape is reported to the person tracker. We have also installed pressure sensors into some of the chairs to improve the reliability of tracking when people are sitting down. These sensors are at known locations and provide reports to the same person tracker as the vision programs. The person tracker integrates the reports from the vision programs and pressure sensors. It uses input from these sensors combined with historical information and person motion heuristics to produce the best estimate of people's locations in the lounge. In addition to tracking people, Easy Living uses a camera to track the position of the wireless keyboard. We assume that the wireless mouse is always near the keyboard. The Easy Living lab gains an awareness of where people and devices are in the room using cameras and pressure sensors. We are also investigating the use of alternative sensors which can determine the location of things in the room. When Easy Living measures the location of a person or device, that information is kept in the world model. The world model is a SQL database using SQL Server that represents the system's current understanding about the location and properties of people and things in the room, like this display screen. Things in the world are represented as polygons that indicate their shape. The world model includes both the shape and the properties of the object, such as the fact that it is a display, the size of the screen, and sufficient information to contact software responsible for managing the display. We also represent the areas of interest around each object, such as the viewing area of this display. Perception software, like the person tracker, records locations of things into the world model. The observations from each sensor are stored relative to that sensor in the world model. We have calibrated the locations of all the sensors so that we can determine the relative positions of objects even if they were measured by different sensors. The world model presents a unified view of the world as seen by all the sensors together. With the information in the world model, Easy Living can make some things happen automatically. For example, the lights in the room have a service area that covers the entire room. When a person enters the light service area, or in other words, when their location intersects the polygon for the light service area, Easy Living turns the lights on. Conversely, when there are no people within the extent, the lights go off. One of the functions of the world model is to serve as an abstraction layer between the sensors and the applications that use that data. If we added another sensor, such as an active badge system, the applications would not have to be changed. The world model is also used to maintain an awareness of who is who. When I first entered the room, I was simply known as person 19. I could control the room lights or play music, but nothing more. When I typed in my username and password, Easy Living examined the world model and determined that person 19 was using the keyboard. Thus, it knew that person 19 was actually me. From that moment until I left the room, the system knew who I was and where I was. Once I was logged in, I could bring up my personal desktop so that my own personal information was available to me wherever I might go. When Brian identified himself using the thumbprint reader, the authentication program used the world model to find the unidentified person who was standing near the thumbprint reader. Then it knew that that person was Brian. The Easy Living system only knows who you are when you choose to tell it. That way, you are in control of what the system knows about you. This is one of the many steps we take to protect your privacy. This is an area for further study as part of this project. Easy Living also lets you move around your computing desktop right in the middle of what you are doing. This is made possible by the world model, which lists all the devices available in the room. Here we see Brian moving his display from his laptop computer to the wall screen in the room. The world model listed all of the available displays for Brian, so he could select the one he wanted to use. We use Terminal Server to move the desktop to the desired display device. But we need something more to make his current mouse and keyboard control the new display. In a traditional computer, devices only work with each other when they are attached to the same PC. Ideally, any set of devices can be used together as if they were part of the same computer. That way, you have complete freedom to use the devices most convenient for you at each moment. This ability is sometimes called disaggregated computing. Here's how it works. Each mouse and keyboard has a program called a proxy that intercepts signals from the actual device. The proxies route these signals between themselves so that the desired devices are connected to each other. In Easy Living, you can even interconnect the display and keyboard of your laptop freely with other devices in the room. Earlier, I was listening to music in the lab using the Easy Living media player. It uses the world model in two different ways. First, the media player shows a playlist in the lower part of the window that includes the music that belongs to me, as well as music that is specific to this room. The media player determines this by using the world model to find all the people in the same room as the screen on which it is being displayed. Second, the audio locations in the upper right represent the possible speakers on which the music can be played back. Entries in green are devices for which I am in the primary service region. Entries in black are devices for which I'm in the same room. Entries in red are located outside of my local area. Again, the world model is queried for this information. When Steve arrives with his laptop, the media player examines the world model and changes the display appropriately. Now, the laptop speakers can be used as an output device. Additionally, Steve's music is available for playback. Steve can change the playback location of his music, in this case, from the laptop to the nicer speakers in the lounge. Making all of this work requires perception software, the world model, device proxy programs, and applications. To make all of these programs communicate and work together reliably, we have built a distributed computing architecture called InConcert. InConcert supports software object activation and lookup and allows communication between running objects using XML messages sent over HTTP. The Easy Living software runs on 15 PCs. The scenario shown earlier required 75 running software modules, 20 of which were distinct pieces of software. Since Easy Living supports both an awareness of people in the room and integration of devices across the network, it can make some things happen automatically. Easy Living has behavior rules that can make things happen under specific circumstances. For example, when I stood up and left the sofa, the session was cleared automatically from the wall screen. Next, I entered the region around the corner PC, so its display was allocated to me. Another rule made sure I had use of the PC's keyboard. To me, the net effect was that my session simply came with me as I moved between places.
Hello.
We also have rules for appliances and fixtures, like the room lights. The lounge automatically turns on the lights when someone enters, and turns them out again when the room becomes empty.
Goodbye.
Awareness of the occupants and integration of devices make this kind of automation possible. Automation may seem like a frill in a small room like this, but as we add more devices and cover more space, it becomes a necessity. Automation is what makes a room like this come alive. It becomes more of an active partner in our daily life, instead of just a room full of dead furniture and isolated computers. Easy Living is a prototype disaggregated computing system which has an awareness of the room's occupants and devices, integration of distributed devices into a single computing system, and mechanisms to allow automatic control over those devices. We are continuing to explore these technologies and to develop the next generation of computing in the real world.
Goodbye.